Okay, we're going to represent a compound inequality. So from this graph, notice how there's two disjoint points. That means it's an or. The bottom one is an and because it's like all contained in one. So the left part is x is less than or equal to 6. You include the 6. The right part is x is greater than 2. They're separated, so you have to put an or. You can put a union if you want, but I just like putting an or. Now this one, they're all one piece, but there's two rules. It's bounded between -3 and 2. So you can write the compound equality this way: -3 less than x less than 2. Okay. Right here, let's analyze these pieces one piece at a time. So let's look at set A. It's going to be bigger than -1. So I'm going to put that in red on this number line here, and then in black, that's the set B. It's the numbers between -3 and 2 inclusive. The yellow part right there is the part that's their intersection, which is what you would evaluate in part C. But when we look at their union, that's the things where it's all of one guy and all of the other guy. The union is actually from -3 to infinity because it's, hey, all of yours and all of mine, let's combine all our resources. So part A and part B are automatically wrong. Whereas if you look at part C, the intersection, the yellow part, it does line up with the option for part C. Now, as far as the part D, the subset, that notation subset, that's what that means. But it's almost right. It would be right if it said less than or equal to 2, but it just says less than. All right, so mostly you just need to know what union and intersections are there. All right, let's do another one. This is similar to the case we did with the absolute value inequalities, except it's an equation. Using two cases, make one case to where you set the stuff equal to the positive 11, set the stuff equal to the negative 11, and solve the equation like normal. Okay, so the first case you can put as a decimal if you want. The first case, I get 13 over 4 as one of my solutions. The second case, where I set it equal to the negative version, well, I'm going to still add 2 on each side, divide by 4, so I get -9/4. The answer is -13/4 or -9/4. You can check both of those answers. Like I could plug them into my calculator, which I'll do in the next one. I'll show you how to plug into your calculator to check. You can do it by hand, of course. But both of those are going to be solutions to this. You can write them as decimals and proper fractions. But either way, I'm going to put like all of them in one box here. This is a solution, this is a solution, this is a solution. Check all three of those. I don't care what form you put it in, as long as you put like one of those forms of saying, hey, there are two solutions. Let's do this one similarly, and this time I'll show you what I mean by checking it. So the two cases, set it equal to the positive version, set it equal to the negative version, and then I'm going to solve it like I would any equation. I think these are my two solutions, and I could write that in the roster form notation. You don't have to write it both ways. Pick whatever your favorite way to write it is. Here's what I mean by the check. I'm going to look at my calculator. I'm going to I'm just do these by hand. Okay, so if you take -33, add 10, you get -23. Absolute value of that, you get 23. The other one, you get absolute value of 23, which comes out 23, so they check out. All right, the next one, before you do the two cases, you want to get the absolute value parts by themselves. So I'm going to set it equal to the positive version, set it equal to the negative version. This time, I'm going to solve them simultaneously. So subtract 1 on each side in both cases. Divide by 3 on each side in both cases. Your solutions are 16 thirds, or and -18 thirds divides evenly. It's -6. It's 16 thirds or -6. I could check it by hand, but just to show you how to do it in your calculator, you do absolute values. There's three ways to do it. You can see here. I do second catalog, or I go to math, or I go to alpha window. All of those ways get you absolute values. I'm plugging in 16 thirds in place of x. Notice how when I do that, it comes out to 13. Here, instead of retyping all that, I'm going to delete the 16 thirds. I'm going to replace it with a -6. And notice how when I do that, I check it, it comes out to 13 again. So that's what we mean by checking your answer. You can always do that on an equation. All right, this one, same thing. Before I do the two cases, I want to get the absolute value pieces by themselves, divide by 4. Do not distribute that 4. Weird things can happen if you try to do that. So I just divide by 4 on each side. And then I just solve the equation like normal. I have two different cases, so two different equations, so I'll get two solutions. But I subtract 5 on each side. One solution is t is equal to 0. Here, subtract 5 on each side, but I get negative t is a -10. So that means positive t is a positive 10. So my two solutions are 0 or 10. That's my solutions. I could put it in roster form if I want. I could put like 0 and comma 10. But here, I'm going to check the solution. I'm going to go 4. I'm going to do absolute value in my calculator by second. I like to do second catalog. And look, you check the 0, and the 0 works out. Now, instead of putting the Instead of putting that, I'm put positive 10 in there, and look, it checks out, so I can always check my answer in an equation. All right, little applied problem here. We want to raise at least $500. At least. That usually means greater than or equal to. So I can sell 50 tickets at $5 each, and I sell an unknown amount of tickets at $7.50 each. I want to solve for that unknown amount of tickets. I use T just because it stands for tickets. I could put the equation this way. If you and again, I want it to be at least 500. If you want to put it in the other way, if you want to put $5 times 50, $7.50 times T, you can write the equation that way. It doesn't matter. If you don't like putting the dollar signs, I'm going to put it here without doing the dollar signs. But either way, I'm going to put some variable there. So in the first two equations, I have the dollar signs just so you see where I'm coming from. But I'm going to simplify this equation. Then I'm going to isolate the variable t. So I'm going to subtract 250 on each side. Then I got 750 times t. So I'm going to take 750 times t. And I got that's greater than or equal to 250. Divide by $7.50 on each side. I'm going to go ahead and run that in my calculator. I'm going to divide by 7.5 instead of 7.50. And here's the answer I get, 33.3. Well, so 33 tickets wouldn't quite be enough. So to reach the goal, you'd have to do 34 tickets, which would put you over your goal, which is fine. So the answer is actually 34 and not 33. You don't just round down because 33 wouldn't make you meet your goal. So you have to say 34. Here I'm going to use a Venn diagram to draw this. And actually, instead of doing those colors like this, let me do them to where one of them is a yellow Venn diagram. And I'm going to make the other one a blue. And since yellow and blue combine to green, I'm going to do it like that. So the intersection, I'm going to call it the green. They give us just the yellow, which is like just the people who do weekends. And they give us the intersection, which is 63. Now, altogether, there's 145. So that means to figure out the people that are only the people who run during the week, I just subtract, and I can get the people who are the ones who are only the blue box or only the blue circle, which is the people who are only run during the week, not the ones who do both. This is an open-ended question just to help you get an idea. I'm going to write an absolute value inequality that has 3 and -5 as solutions. I'm going to do at least 4 different versions of this just so you can get an idea of how you could solve it. I'm just kind of counting from -3. I'm trying to see where the center of these two numbers is. I could have just taken the average of 3 and -5, but you come out to -1. Each of those numbers are a distance of 4 away from the number -1. So if you do x minus -1, those are exactly a distance of 4 away, so they're within 4 away. Instead of doing minus negative, I could just do plus. These are 2 different examples that could be problems that have these as solutions. I could do less than or equal to or greater than or equal to. Those would both be problems that have those as solutions. Instead of it being exactly 4, I could say, okay, what if we're within a distance of 5 from -1, and just to see what that looks like graphically, like the numbers -5 and 3 would still fall within a distance of 5 of -1. Or I could say they have to be a distance greater than 1 away from -1, and eventually those would collect the numbers -5 and the numbers +3. So these are all different kinds of answers that could have these numbers as a solution. One thing you need to know here, don't forget this. When we're dividing by a negative in an equation, nothing's really important, but watch what happens when we do it with an inequality. If I divide by -8, okay, I just get 16 divided by -8 is -2, that's fine, but watch what happens when I divide by -8 in inequality. Don't forget to flip the symbols. Just give you a little more practice. It's not just when you divide by a negative, but also when you multiply by a negative. You have to flip the symbol. So all we're doing here, this is just a study tip to remind you to flip the symbol. Here they're asking us to define the region C. Notice that C is not in either A or B, so it's not in the union of A and B. So when it's not that means it's the complement of A union B. So it's everything that's not either A or B. And for the final one, what is the most elements a subset of 9 elements could have? Well, since every set can be a subset of itself, it could actually have 9 elements. So just think of this as a situation. If you have 9 buffet items to choose from, you could eat all 9 buffet items. So that's it for the study guide. Good luck on your tests.